So today we have here Andreas Gysin, a Swiss-born graphic designer and generative artist. I really like to thank Andreas because he's come all the way on his own. Thank you very much. As Monica said before with Maria, I'm a huge fan of Andreas' work. It's been a pleasure to have you here. And today he will be presenting a couple of projects that revolve around screens and their limitations, along with new plotter works and unorthodox uses of the plotter. So I leave you with it.
Thank you, Xavi, and thank you for having me, and thank you for coming. So I'm going to present a couple of works from the last 5 or 6 years, more or less. And I have a graphic design studio, so that this is my background. And I work with geometry and with images as a day job, but I also have this more experimental part of the studio. And there is a fascination with devices and screens and things that are meant to bring information, so things that are built for this exact reason. And so there starts a thought behind all these projects or behind all these devices that is, what kind of content is the best content for this kind of device? And the question goes further. So the content should not express itself, but it should bring the characteristics of the device into the foreground. And so the first project I'm going to show is, for me, the most complex of the surfaces or the communication devices, which is the screen, the computer screen or the phone screen, which is basically a sort of a blank canvas. So everything is possible. You can put movie images, you can do your work, emails, and read, and a lot of other things. So I gave myself a limit, and I told I would only work with text. So every time I do an experimental work on the computer screen, I would work with text so I can limit the possibilities. I don't have to deal with shapes. I don't have to deal with images or movies. So text would be the main object to investigate. And this is a piece of code. There is a character missing on the bottom. And I don't know if you recognize it. This is an SVG file. SVG is a markup like HTML. It's an XML, basically, file, which can also run some code. And so the first couple of lines you see on top, they do an introspection. They read out the code of the file itself and they put it on the screen. So what you see is the actual code with a couple of missing characters, which is displayed. There is also some strange formatting. I mean, I guess there are a lot of programmers here. You usually don't write code like this, but there is a reason. I might eventually cover it afterwards. And so the first part displays itself, and the second part then animates and starts to modify all these characters. And so this happens. I made a series of these experiments. It's still an ongoing series. I started a couple of years ago, and I've 9 for now of these projects. I can show you a few. It's a bit more choreographic. There's also more lines. I also tried a little bit more an organic approach, so to break the rigid grid of these characters. So this looks a little bit like a shrimp or something like this. This one destroys itself. And so this is also the first one where I found a technique to use proper indentation. So this is the actual representation of the file. So if you open this file with a text editor, you will see exactly this. This is from a couple of years ago. This one, this block you see on the top, this is a bitmap. A bitmap is a graphical information of a black and white image, and the image is numbers. So this code gets translated into numbers. They all have some titles, these pieces, and the title of this piece is Code is Numbers. And this is the last one, or it's not the last one, but it's the last one I'm going to show. It's my favorite. This code tries to sort itself in alphabetical order. So the missing part is because this is a screen capture, and so the record is missing just the first frame. So this what you see is not the actual code. I thought it would be trivial, but it turned out that it was a difficult task. So this is a mistake. Then I tried a different approach. It didn't work, but it started to look interesting. This was already a little bit better. You can see the sorting works, more or less. I mean, alphabetical sort. And then I think this one is probably the final one. And there is a sort of debug inherent in this code, because you see the number of parentheses that open is the same as the number of parentheses that close. This means, it means something, especially in the code. And I will have a last screen work at the end of the presentation, but I want to show you two plotter works. This is a modest plotter. You know this simple object. It's also, you can get this for quite cheap. But here the question is the same. What kind of content do you put on a machine that is able to reproduce any geometric information that you send it? And how can you make something that only this machine can make and not a human, for example? So even a human, you know, in the art history, in etching, for example, detail is something men can do by hand. So an extremely detailed or photorealistic image, a machine can do, but also a human can do. And so we were looking for content that only this machine can do, but not a man, or you cannot do by hand. Yeah, so it's a bit long, so maybe I can move forward a bit. So this is real time. It's not a drawing. The data is sent to the plotter directly. And so this is a series of 100 drawings. They look like this. But the thing that keeps them together is that all these lines, they're exactly 1 meter long. So that's something you cannot do by hand. And they look like this. And this is a second unorthodox use of the plotter somehow, which I'm going to show you today. This is also an ongoing series of 28 video loops. And this is just a LED strip put on the arm and a digital camera on front of it. And the idea is simple. It's a long exposure image. And here again, we use the plotter, which is able to replicate the same drawing more over and over, and it's also possible to change one parameter at each take. So the idea was to build a series of images and then put them into motion. And so this was the first attempt. It was okay, more or less. We got better. It was still very difficult. And then at a certain moment it clicked. This is still in between, but as it's a physical device, you can have you can have reflections for free. So if you do real-time rendering, you know that reflections are hard or take a lot of GPU power, but in reality, you put a mirror and then you have reflections. And so this was the first moment where it clicked. And so we managed to get a proper image out of it. So you can see these steps, they are quite precise. And this is how it works. This is the generation of one frame. So everything is synchronized. The motion of the robot, of the plotter, the sequence of the LED, and the DSLR camera, they are all driven by the same program. And one frame takes more or less 1 minute. And that's how it looks. slowly. And then you make hundreds of these images and you put them into sequence. This is an object to test, a test card for the plotter. This is how it looks, from very professional. And this is a couple of results. So these are meant to be video loops, but it's completely analog. I mean, the capturing of the image, but of course the process is completely digital. And it's also strange reasoning because in the horizontal motion, you have basically continuous space, but in vertical, it's you move by steps, so it's discrete. You can see here, it's the arm that wobbles after doing a corner, so it vibrates a bit, and it brings this sort of vibration with it. And this was started in the design studio. This was a commission first, but then the project failed, and we continued on our own this exploration. So displays, back to displays, 7-segment numbers. Many projects have studied around these things. So we managed to get a couple of electromechanical ones, and we build this thing. So this should run. So if you start to concentrate not on the numbers, but on the shapes, then you can come up with forms like this, which are part of the screen, but not in the way when you use numbers to display. So this was an experiment around the geometry and the sound, of course. So we tried to make shapes with these segments. But then we have another version where the topic was speed. You know, maybe this object, it's an object made for public space, an object to communicate something, some content, but it's also an economic, it has also an economic feature. You, as an advertising agency, you can rent the same place for 3 people that want to put some advertisement in. So the same surface times 3. And it's a prismatic display. These elements, they turn. And they have a little bit of scenography inside, so they don't turn in the same moment, but they have some sort of wave. And so again, the question was, what can we put to enhance this wave idea to the maximum? And this was one solution we came up. There is a sort of an optical illusion. It almost looks like they are turning in the opposite direction. So we thought it was an interesting approach, more or less, for this kind. We did another experiment with color, but I think it didn't work so well. So I think the one before is much better. But we had 2 of these things, so we could at least experiment. Also, it's really hard to print industrial colors on a thing like this. So there are some problems with this kind of gradient. Another display, another story. So this is the main station in Zurich. This is the old timetable. It's 7 tons, 12.5 meters. And we knew that they were going to take it down. And we discovered this while traveling by train. And so we arranged that we could take it. And so they gave it to us. The Swiss Railway gave this thing to us. We should be ready to take it when they took it down. This was the moment they took it down, midnight. And in the same night, they would put a digital one. So there is no interruption of the service. They packaged it and they transported it into a museum, the Muda in Zurich, where we rebuilt it. And also we reprogrammed it. You usually don't get these things with a manual, so you have to figure out how to program these things. Also, there was a super thick cable on top that came out, and they just chopped it. And then when you look in this cable, you have like 20 small cables, and you have to figure out what each of these does so that you can reprogram it. But again, this is a display. This is not a alphanumeric display. You cannot write whatever you want. These train stations, they are written on these elements, and an element is this big because there are only 60 stations, and so there is no need to have an alphanumeric surface. And so this is the kind of content you can put. And so what do you do with this when you cannot write? And this was the 5. Mechanical. And so you treat text as an amount of whiteness and not as words anymore. And this was the approach. So this is one element. And if you want to address and treat it as a value system, then you have to do this operation. So this is the same elements reordered. I mean, they are reordered by software, not physically. You cannot do this. And that's how you start to design and to reason around this piece. So I skipped this project. I wanted just to go to the last. And so this is also an ongoing project. And this is a display from 1984, nice date. It's a digital vector display. It's used in scientific context. And some times ago, I found a ROM dump of the firmware of this thing. And this thing has a font ready inside the display, ready to be used. So I got one. I also got the manual. It's not something for the weak. And it looks more or less like this. So it's an analog cathode, but all around there is a digital interface. So this is not an oscilloscope. You talk to this thing digitally, even if so it has an analog part, of course. And so this is the font that I was able to extract from this ROM dump, which is already inside the display. And so it's nice to use what is already there. And so this is my trusted engineer trying to make it work somehow. We had to build a controller. And so this is the first approach, more or less. As you can see, this display doesn't have pixels. It's a vector display. So the line is super smooth. And to see this in reality is really something else. And so this is more or less this image was shot yesterday in my engineer studio. He sent it to me so that I could put it into the presentation. But also this is a part, I made this as an edition. This was a commission project, and I used the money that I made from this work, which uses the same font, so it's somehow connected. I used this money to finance the project, to pay my engineer, to have the time to develop the hardware and the software, and so on. So I always like to finish a presentation with something that is in the work right now. So thank you very much.